All right, so here we are. We're talking function notation. So remember, function notation is kind of a name I can give so that you can recognize, remember we talked about graphs and you could recognize which graph we're talking about, if we're talking about F or we're talking about G or we're talking about H. The other thing was that you have these inputs. So you remember on the graph, I might say, find F of 60, and we were talking about at 60 seconds, how far away was the dog? And then you would have your output answer like 4 feet. Okay, so here you have your input. So our input, and then we get our output, our answer. Well, we're talking about equations now. So what if we're not talking about graphs? We're talking about equations. Our input is our x, so we put our x in that spot, and our output is the y. And so really what you're doing is you're replacing y with an f of x. So normally I would have an equation like y equals 2x plus 3. But now instead of a y, it's my output. I want this to be what f of x equals. So a lot of times you're going to see an f of x instead of a y. Okay, so we'll put an f of x there. So you can see I have examples over there on the top left, right? So we have f of x equals x plus 3. We have g of x equals 2x minus 5. And then we have h of x equals x minus 1. And so here's one way that function notation works when you have equations. Maybe I want you to plug in a number. So instead of f of 60, maybe I want you to find f of 1. So if you notice, instead of f of x, I am now writing f of 1. So I have replaced the x with a 1. Which means now in the rest of my equation, so if I look at f of x, it says the equation is x plus 3. So instead of the rest of that equation, I am now, wherever I see an x, I am going to put in a 1. I like to use bubbles when I plug in, just in case there's some multiplying going on. Now in this case, there isn't, so it's just 1 plus 3, which is 4. So for my input, and I can make an input-output table here, right? For my input, I plugged in a 1. And I got a 4 as an answer. Okay, so this is if I'm talking about f of x. Okay, so I could keep on doing that. I could now put this down. And if I put that down, what you need to know is now you're going back to your equation. So we're looking here, we're going back to our equation, and we're plugging in 0 now instead of 1 for the x. And then we get our answer. Okay, so here's where the cool part about function notation comes in, is what if I want something, I want one of the other equations. So we try not to use words, we try to be as efficient as we can. And instead of using words and saying, now go to the second equation, now go to the third equation, I just use my function notation to tell you really smoothly, it's really quite smooth and clever, what I want you to do. So I could give an example like, I want you to find h of 4. And so when I say h of 4, I'm saying go and plug in 4 for x in the h. So here's our h. So I'm going to plug in 4. So I get 4 minus 1. And then 4 minus 1 is 3. So h of 4 is 3. Or maybe I want you to find g of 1. So then I'm going to the g equation, and instead of x, I'm going to put a 1. So instead of 2 times x, I'm going to say 2 times 1 minus 5. And then I can do my math, and I get -3. And this is why we've been working on all of our positives and negatives, because you're going to have to be able to do all that. And I want you to be able to do all that without a calculator. Okay, so that's what we're doing. We're just giving you random things. And I want you to know what to do with that. Which equation do you use, and what do you do with that 10? You put in the 10 wherever you see an x. And sometimes you might actually see more than one x. So what if I had g of x equals 2x plus 3 plus 4x? And I want you to find g of 2. Now let's make it interesting. Let's make it a -2. Okay, so now what I'm going to do is wherever I see an X, I'm going to plug in -2. And then I have +3, and then I have +4, and I have another X. So I put in another -2. I put it everywhere I see an X. So then I get -4 +3 plus -8. And I do that, and here I got some 0 pairs, so I got -1, it's -8, and then I put those together, I get a bunch of negatives, and I get -9. So no matter how many X's you have, you plug it in for all of them. And it doesn't matter, actually, what if it's not an X? What if it's V of t equals 600 minus 2t? So by the way, I knew I was using t because I had a t right there. So that t right there tells me what variable I'm going to have following. So if I had an x after the equal sign, we would know something's weird because it was v of t. So I should always have a t then. And so then if I want to find v of, let's say 0, well, then I would just plug in 0 for t. And I would go ahead and 600 minus, well, 2 times 0 is 0, and 600 minus 0 is 600. So that is function notation with equations.